Okay, hello everyone and welcome. Guys, this is our third day talking about functions. We'll call it function C. It's the C day of functions. Today, guys, we're going to identify the points of maximum, minimum, and the intercepts of the function. Okay? So we're going to identify points here today. Guys, the essential question, and you need to know this for the homework check, what are the extremes and the intercepts of a function? Right? The extremes are the max and the minimum. Guys, just to review, remember a function, it's a relation for which each input has exactly one unique output. That's a function. Guys, and if we graph a function, it should pass the vertical line test. No vertical line should intersect that graph at more than one point. Should intersect the function curve at more than one point. Any vertical line, anywhere. Again, to review, the domain of the function is the set of input values, or the x values. The range is the set of output values, or the y values. The intercepts are the points where the graph crosses or touches the axis. Okay, the x or the y axis. Those are considered the intercepts, okay? As an example, here we have a function. It's a quadratic. It's upside down. For this function, the x-intercepts, again, are at -1 and 0, right there. And right here, 3, 0, this point right here. The y-intercept is up here, all right, at 0, 3, that point right there where it crosses the y-axis. Crosses or touches, okay, either way. Guys, where a function crosses the x-axis or touches it, it's often called the zeros or the roots of the function, because that is where the output of the function equals 0. Oops. Crosses or touches the x-axis. All right, those are called the zeros. The x-intercepts are the zeros. Now, a function may have many x-intercepts. It may have many zeros. This is like a sine wave. It hits the x-axis a whole bunch of times. But it can only have one y-intercept, or else it's not a function, because the y-axis is a vertical line. And if it hits that curve in more than one place, it's not a function. Okay, it can only have one y-intercept and still be considered a function. The maximum value of a function, pretty simple, it's its largest value. It's its largest y value, output value. The value of the function itself is the y value. It's often the point where the function goes from increasing to decreasing, okay? Like right here, the maximum value. The minimum value, on the other hand, is the smallest value, of course. It's the smallest y value. That's the smallest value of the function. And it's often where the function goes from decreasing, boom, to increasing. That's the minimum point. Guys, as an example, the minimum value of this function here is 1. The minimum value of the function is 1, and it occurs at where x equals 2. So we say the minimum value is at point 2, 1, okay? Now this particular function has no maximum value because it goes up forever. All right, infinity is not really a maximum value. All right, this has no maximum. It keeps going up forever. Get another example, the maximum of this function, because it tops out right here. The maximum is 4. All right, look at the y value. That's the maximum value, 4. And it occurs when x equals -3. So we call, again, that point is -3, 4. And again, this function has no minimum value. It goes down forever to negative infinity. It has no real minimum value, okay? All right, y'all, that's it. Next, please complete the homework check. And these are today's vocabulary words that you'll need to know for that. All right, that's it. Thanks a bunch.